Hi everyone, we are going to continue today with word problems. We're going to stick with quadratic equations, so not much is going to be new, except we're just going to use these words to set up the equation. So if you are struggling, please contact me and we're going to do some extra help. But what exactly is a quadratic equation? How do you know you're looking at a quadratic equation? It's usually in this form, ax squared plus bx plus c equals 0. And you know you see a quadratic equation because right here, your highest exponent is 2. Okay, so you really got to know what that looks like. So we are going to take these equations, we're going to read what's going on, and we're going to solve. So today we are talking about Brian. Brian is 3 years older than Doug, and the product of their ages is 40. So you have so many keywords. They want to know how old Doug is. Well, you know, Brian is 3 years older than Doug. So remember these good old let statements? We know nothing about Doug. Doug has to be X. Let X equal Doug. Well, what do we know about Brian? Brian is 3 years older. So how would I say 3 years older? X plus 3 is Brian. Okay, and now they tell us the product. What does product mean? It's the answer in multiplication. Is another key word. It means equals 40. So how would I show multiplication of Doug and Brian? X times X plus 3. When I say times, I show it with parentheses. That's the best way to show multiplication. And their product equals 40. So now we solve. We distribute X to both terms, and we get X squared plus 3 times X is 3X equals 40. So again, just like a little reminder, remember that X times X is X squared, or X to the second. X plus X is 2X, okay? Just like a little helpful hint. Now, when you look at that equation, it's not in standard form. It's not equal to 0. So we are going to move that 40 over to the other side. And there's no like terms with 40 or minus 40, so it just gets brought to the end. It's your C value. This right here is a perfect trinomial. It's a trinomial, so that immediately gives you that little puzzle. What multiplies to negative 40 and adds to 3? It's got to be a different sign. So I'm thinking positive 8, negative 5. If you wrote negative 8 and positive 5, those would add to negative 3. You want the 8 and the negative 5. So I'm going to use X plus 8 and X minus 5. Now when I set up my little t and I solve each mini equation, I have X plus 8 equals 0, X minus 5 equals 0, and when you subtract the 8, I get X equals negative 8. And here, when it's subtraction, I'm going to add 5 to both sides, do the inverse operation, and X equals 5. So now let's just think about this. Normally, you would say, I'm done. I have 2 answers, negative 8 and positive 5. But in this situation, can Doug's age be negative 8 and positive 5? No. Which one can it not be? It can't be negative 8, okay? Age, when we're here talking about age, cannot be negative, okay? So we could kind of reject here that negative answer. That immediately gives me my answer that Doug's age is 5. Now let's say they wanted to know Brian's. Well, if you now know X is 5, add your 3, and you know Brian's age is 8. Okay, so understand that 5 is your answer, but you could find out everybody's age just by setting up those let statements. All right, let's kick it up a notch. Let's talk about these 3 brothers. You have 3 brothers, and they have ages that are consecutive even integers. So a little bit different. If you know your first brother, which we know nothing about, is X, first consecutive even integer. And now let's talk about your second brother. Well, what do you have to do if, let's say we pick any even number, 4, and I want to get to the next even number after 4, which would be 6. I just add 2. So that's your second consecutive even integer. And now from there, if I'm sticking with that 4, and then I go to 6, and then I go to 8, from my original x, I would have to add another 2, which would give me 4. That would be my third consecutive even integer. Okay, so that's not the hard part. The hard part is now describing and reading through and translating. It says the product multiplication of the first and the third boys' ages. Okay, so let's show that. The product of the first, x, and the third, x plus 4. So x times x plus 4. The product of the first and third boy's age is equals. Okay, now it says 20 more than twice the second boy's age. Here's the second boy's age. How do I show twice the second boy's age? Multiply it by 2. 2 times the second boy's age, and I'm going to put the plus 20 after it. Now, you could have done 20 plus 2 times x plus 2, but you at least have to show the addition is commutative, but I just like to put that distributive property in the front. It won't matter. You should still get the same answer. So now I am going to do a lot of work here. I'm going to distribute on both sides. So again, x times x is x squared. X times 4 is 4x. And that equals 2 times x is 2x. 2 times 2 is 4 plus 20. So now on this side, I can combine like terms. I have x squared plus 4x equals 2x plus 24. I'm going to move this 2x over to this side. Those are like terms, so I get x squared plus 2x. Now that equals 24. I don't want 24 on that side. I want it equal to 0. So when I move it to this side, I have x squared plus 2x minus 24 equals 0. And once again, you're looking at a trinomial. A equals 1. There's no number in front here. So you're going to just pull off negative 24 and ask yourself what multiplies to negative 24 and adds to 2. And it's got to be 6 and negative 4. So I'm going to open up and put an x plus 6 and x minus 4 equals 0. Set up my t. X plus 6, x minus 4 equals 0. Again, when you undo that 6, x equals negative 6. And when you add your 4, x equals 4. Now, are they both able to be brothers' ages? Hopefully you're all saying no. This one we have to reject it. It's literally, you don't have to write this, but we're rejecting it. Age can't be negative, which means the first brother's age is 4. He's a 4-year-old. What's the next brother's age? 6, add 2. And the next brother's age, if I took the original x, 4, and added 4, 8. Now, they ask you to find the youngest brother. Here's your youngest brother. 4-year-old is the youngest brother. Okay? All right, soak that all up. Let's take a look at this next one. They're talking about a right triangle. So the first thing I'm going to do is draw a right triangle. Now, I hope everybody knows a right triangle is just a triangle with a 90-degree angle, okay? And it says the shortest side of this right triangle is 5 inches. So I'm going to make this side my shortest side. Here's what I do know, that this side right here is what we call the hypotenuse. And the hypotenuse is always the longest side. Okay, so then it tells me that the lengths of the other two sides are represented by consecutive integers. So what are consecutive integers? Well, one of them would have to be x, and the other one would be x plus 1. Think of consecutive numbers, 5 and 6. X and x plus 1. Whatever number you have, to get to the next number, you would add 1. The hypotenuse has to be the longest, so it has to be x plus 1. So now it says find the lengths of the other sides of the hypotenuse. Find the lengths of the other sides of the triangles by setting up an algebraic equation. So let's just talk about that algebraic equation. If you had to actually solve for those sides, does anybody know what the equation is? for a right triangle to find the side lengths. I wonder if you guys all know this, the Pythagorean theorem. And the Pythagorean theorem states that a squared plus b squared equals c squared, okay? And you have to know that your legs are kind of your a and your b, and your hypotenuse is always your c. So that would mean your a could be 5 squared, your b can be x squared, and your c, that whole thing, x plus 1, would also have to be squared. All right, so let's try to solve this. 5 squared would be 25 plus x squared equals, this is just x plus 1 times itself. Okay, so now you have 25 plus x squared equals, when I double distribute, I get x squared plus x plus 1. Now this is interesting because here, if I minus x squared, guess what happens to the x squareds? They're gone. And now you have 25 equals, these are like terms, 2x plus 1. So I'm going to move my 1 to the other side, and you wind up with a linear equation, 24 equals 2x. So if I bring it up here, 24 equals 2x, and I divide by 2, I get 12 to equal x. So x equals 12. That tells me this side is 12. Can you figure out the third side, the hypotenuse, the longest side? Just take 12 and add 1, which is 13. So your three sides are 5, 12, and 13. And if you didn't know this, this is what we call a Pythagorean triple. And you guys will learn all about those next year in geometry. Okay, I'm going to try one more with you. Everybody take a look at number 4. It's John and Sarah, and they're saving money for a car. Okay, so the total amount of money that John will save is given by his equation, y equals 60 plus 5x. The amount of money that Sarah's saving is going to be given by the equation, y equals x squared plus 46. So after how many weeks will they have this same amount of money? So now look at this. If y equals this and y equals this, then they both have to equal the same thing. Does everybody understand that? You're going to immediately set them equal to each other. Okay? And I want the x squared on the left-hand side, so I'm going to write x squared plus 46 equals 60 plus 5x. But you could have put 60 plus 5x equals x squared plus 46. It doesn't matter. Here's what I will say to you. This x squared must be positive. So wherever your x squared is, keep it positive. In other words, I am now going to subtract 60 from both sides. Okay, x squared is positive on the left-hand side. I'm keeping it there. So now I would have x squared. When I take 46 and subtract 60, I have minus 14, and that equals 5x. Now again, I don't want it to equal 5x. I want it to equal 0. So I'm moving the 5x. Look where I move it. This is so important. Remember this standard form, ax squared, then your bx term, then your c, which is your constant, just a number, then equals 0. So look where I'm putting my x term, my bx term, in the middle. X squared minus 5x minus 14 equals 0. And now I have a quadratic. I have a basic trinomial. What numbers multiply to negative 14 and add to negative 5? Negative 7 and positive 2. Has to be negative 7, because if you pick 7 and negative 2, then these would add, if you added those up, 7 plus negative 2 equals positive 5. But negative 7 plus 2 equals negative 5. These are the two you want. So I need x minus 7 and x plus 2. Okay, when I set that up, x minus 7 equals 0, x plus 2 equals 0. If I add my 7 and move it to the other side, x equals 7. And when I minus 2, I get x equals negative 2. Now, in this situation, if we're talking about x, which is the number of weeks, can both answers be your answer? Hope everybody is saying no. Can you have negative number of weeks? No. Weeks can't be negative. So it depends on what we're talking about. Length can't be negative. Weeks can't be negative. Age can't be negative. So here is your answer, 7. Your answer is in 7 weeks. Okay, I'm going to give you guys some practice and see how it goes. Please contact me if you need some extra help. Let's do some extra help. Okay, talk to you guys soon.